Hello students. So today we are talking about alternating current. Alternating current. So here we are discussing some concepts about alternating current. Okay. So once again, why physics concepts are tough? So we have to repeat the concepts, repeatedly revise the portions. So this will help you to study the things. So we are discussing now about alternating current. So alternating current means first we can say that alternating current is like a sine function with time. So the alternating voltage, AC voltage, so we can say that AC voltage is a sine function with time. AC voltage is a sine function with time. Such voltage is called alternating voltage. So the current driven by it in a circuit is called AC current. So AC voltage is a sine function with time, a voltage which that varies like a sine function with time. It is a voltage which varies like a sine function with time. The current driven by in a circuit is called alternating current. Alternating current, that is also known as AC current. Okay. So next we know that most of the electric devices we use require AC voltage. This is mainly because most of the electrical energy sold by power companies is transmitted and distributed as alternating current. The main reason for preferring use of AC voltage over DC voltage is that AC voltage can be easily and efficiently converted from one voltage to the other by means of transformers. So why AC is more preferable? So why AC voltage is more preferable? Because AC voltage can be easily and efficiently converted from one voltage to the other. So it is easily and efficiently converted from one voltage to other by means of transformer. Okay, you understood about this? Okay, so electrical energy can also be transmitted economically over long distances. So this electrical energy can be transformed economically over long distance. So next we are studying about representation of AC current and voltage by rotating vectors. Okay. So now we studied about just introduction. AC voltage is a voltage varies like a sine function with time, and alternating current, that is the current driven by it in the circuit, is called a alternating current. So we can represent AC voltage as voltage time as a sine function. Okay, like this it is going. And why AC voltage is preferable than that of a DC voltage? Because it can be converted from one voltage to other by means of a transformer. It is easily and efficiently can be converted, and also this electrical energy can be transmitted economically over a long distance. Okay, and next we are studying about the representation of AC current and voltage by rotating vectors. Okay, so representation of AC current and voltage by rotating vectors. So you think about this. Okay, so how we can represent? So in order to show phase relationship between voltage and current in an AC circuit, we use a notion of phases. So what is a phasor? Phasor, so it is a new word to you. Phasor. Phasor is a vector which rotates about the origin in anti-clockwise direction with angular speed omega. Okay, phasor is a vector which rotates about the origin in anti-clockwise direction with the angular speed omega. So phasor, we can represent the first point, it is a vector which is rotate about the origin. Rotate about the origin in anti-clockwise. Anti is anti-clock. You know that is anti-clockwise direction with the angular speed. Angular speed omega. Okay, so it is a vector. It rotates about the origin in anti-clockwise with an angular speed omega. Okay, so how we can represent this? Here it is. Sorry, this y-axis is just this is represent y-axis, it represent x-axis, and this represent the voltage V, and this is the angular speed omega t. Angular speed omega t is the angle, and here angle is omega t, and the length of each phasor represents the amplitude or peak value of the voltage or current. So in phasor diagram we can represent this a voltage or current. So here we represent voltage, so that length represent, so the length of the phasor represent amplitude. Okay, you understood? The amplitude of amplitude or peak value of voltage or current can be represented by the length. Okay, so the length is represented by the peak value, that is represented by Vm, and projection of each phasor on vertical axis gives the instantaneous value of the quantity that the phasor represents. So the projection of the phasor, so you know that the projection of the phasor on vertical axis, you know that this is the vertical axis, gives the instantaneous value of that quantity of the phasor represents. So the rotation angle of each phasor is equal to the phase of alternating quantity. So the rotating angle of each phasor represents the phase. So the phase is omega t. Here the angle the rotation angle represents the phase. So the angle is phase, and projection on which axis? Vertical axis gives what it gives? It gives the instantaneous value of the phasor, okay, of that quantity. So angle between two phases which give you the angle between two phases. If the diagram represents a which consists of two phases, the angle between two phases represents the phase difference between the corresponding quantity. So the phasor is a new term to you. The phasor is a vector and which is rotating along about the origin in anti-clockwise with the speed omega. And the phasor length represents the amplitude. Length represents amplitude, angle represents phase, and the projection of the phasor on vertical axis will give you the instantaneous value of the phasor quantity. And if there is a two-way phases and the angular difference between them will give the angle between that two phases will give the phase difference. Okay, so these points are correct for you. It is clear for you. Okay, and next topic. So you understood about phasor and all the things. Now we are going to AC voltage applied to the resistor. So the next topic is AC voltage applied to resistor. So you know the resistor notation and all. So you consider the figure. Here it is represented AC voltage. You know the representation, and we are considering AC voltage is applied to the resistor. So here we are considering a resistor here. Okay. So this is the figure. This is the AC voltage is coming here. So the AC voltage, the value, this is a sine wave. We know that the representation is Vm sine omega t. Vm is the maximum of that value, that peak value of voltage, and sine, we know that obviously the AC voltage is a sine function and omega t is the phase. So the AC voltage is coming to the resistor. Resistor is represented like this, and apply Kirchhoff law. We know that the Kirchhoff law, you know that the Kirchhoff law, sum of voltages is equal to 0. So the loop rule, we know that in a loop, sum of voltages that is EMF is equal to 0. So we know that here the voltage is Vm sin omega t, and here it is minus IR. Okay, that's equal to 0. The sum of voltages is equal to 0. So Vm sin omega t minus IR is equal to 0. So how it comes IR? We know that Ohm's law, V is equal to IR. So the voltage across a resistor, that is equal to IR. So the sum of voltages in a loop is equal to 0. So from that we get Vm sin omega t is equal to IR, and I is equal to Vm divided by R. I is equal to Vm divided by R sin omega t. Okay, you understood these things? So I is equal to Vm by R, can be represented as this. Vm is the peak value of voltage, R is the resistance. So Vm by R will give you the peak value of current, that is represented by Im sin omega t. So we can get the AC voltage through a resistor will give you the current expression here. the peak value of current, and current is also a sine wave, and I is equal to Im sin omega t. Im is equal to Vm by R. You should remember these things. Okay, so Im is the amplitude of the current. Okay, so you know the thing in AC applied to a resistor, I is equal to Im sin omega t. Okay, okay, you understood? So the graph of the voltage and current across a pure resistor versus omega t can be represented like this. Here we can represent omega t is the angle, we know that, and the graph of a sine, this is a phase of that, and we can represent it is a sine wave. Sine wave we know that like this only, and here we can represent, if it is represent voltage we know that V is equal to Vm sin omega t, current I is equal to Im sin omega t, but we know that Im is equal to Vm by R. So something divided by Vm divided by something, that is resistance of the resistor. So we'll give you a small sine wave for current representation. Okay, not a phase difference, there is some change. We have to edit one more thing. The phase should be same. Oh my god, 1 minute. Okay, we have to draw a bigger graph for, okay, so if the voltage, my drawing is not so good, so it represent voltage. Okay, the magnitude of that the peak value Vm, we know that Im is equal to Vm divided by R. Okay, so that will given by a smaller sine wave, because that Vm by R. Okay, so the magnitude is less, but the phase is same. Okay, phase is same, but the amplitude is decreased by R. Okay, so we know that sin 0 0, sin pi 0, sin 2 pi 0, like that it is going. Okay, so AC applied through a resistor, we know that I is equal to Im sin omega t. Okay, next we have to know about the phasor diagram. Before that, from this graph, what we know, that is in a pure resistor circuit, the voltage and current are in phase. Voltage and current are in phase. Why it is in phase? We know that V is equal to Vm sin omega t, and we did the Kirchhoff law, and we get I is equal to Im sin omega t. So it is in phase because omega t same. So it is in phase, and the minima and maximas are at the same place. So when it is minima, voltage is minima, current is minima. voltage is maximum, current is maximum, like that. So the current and voltage are in phase in a pure resistor circuit. And what about the phasor diagram? What about the phasor diagram? So phasor diagram, we know that it is a vector which represents voltage or current or any phasor quantity. So it represents a voltage V. The length represent the peak value. Length represent the amplitude or peak value. So we know that Vm is the peak value and Im is equal to Vm divided by R. So Im should be less than that. Im should be less than that. So the phasor diagram I represent like this. And but we know that the phase is same, that is omega t. So this represent the phasor diagram for a AC applied to a resistor circuit. Okay. So the AC current varies simultaneously and has corresponding positive and negative values during each cycle. We know that. Thus, the sum of instantaneous current values over one complete cycle is 0. So in this diagram we know that in each cycle there is a corresponding positive and negative values during each cycle. There is a where is that marker? Okay, so here in each cycle there is corresponding positive and negative cycle in each cycle. So the sum of instantaneous current values over one complete cycle is 0. So the average current is equal to 0, and however average current is equal to 0. So that does not mean average power consumed is 0, that there is no dissipation of electrical energy. So we have to find that power. So next we have to find the power dissipated in the resistor. Power dissipated in the resistor. So the one thing we know that the AC current varies sinusoidally and has corresponding positive and negative values during each cycle. So the sum of instantaneous current values during each cycle is 0. We know that each cycle the current, instantaneous values of current over one complete cycle is 0. So the average current is 0. So the average current 0 does not mean that average power is 0. Okay. So we have to find the instantaneous value of power and also the average power consumed over one complete cycle. So we know that power equation. So we next find instantaneous power. So what is meant by instantaneous power dissipated on the resistor? In the resistor, we know that P is equal to VI. All know this equation. So we know that in resistor, AC applied to a resistor, V is equal to Vm sin omega t, I is equal to Im sin omega t. So P is equal to Vm Im sin square omega t. So we get that instantaneous power as Vm sin square omega t. Okay. So So we get power as P is equal to Vm Im sine square omega t. This P is the instantaneous power of AC applied to a resistor. So next we are going to find average power dissipated over one complete cycle. So for that we have to find average. So the average power represented by P bar, that's equal to Vm Im sine square omega t and its average. So we know that the average of sine square omega t, that's equal to half. So P average, that's equal to Vm Im divided by 2. It's like a U, so we have to write one more time. That is Vm Im divided by 2. This is the average power, and we can represent in another way, that is Vm by root 2 Im by root 2. Okay, so we know that root 2 that will give 2. So this can be rearranged like this, and the average power P is equal to, that is represented by, this is RMS value of voltage, this is RMS value of current. So Vrms into Irms. Okay, so the average power is equal to Vrms into Irms, Vm Im divided by 2. So the average power is not 0. Okay, so next we want to know what meant by Vrms and what is meant by Irms. Okay, so you know all these things, no? So we did the resistor voltage applied to AC voltage applied to a resistor, and we did Kirchhoff law here. Okay, why did this? When it is positive or negative, when the current flows in this direction, this direction means current direction we should take minus plus in through a resistor. So Vm sin omega t minus IR. Okay, that will give you I is equal to Im sin omega t, V is equal to Vm sin omega t, and we know that the phasor diagram, they are in phase, and the sum of instantaneous current values during each cycle is 0, and instantaneous power is the just multiplication, and the average power is that is Vrms into Irms. Vrms equal to Vm by root 2, Irms equal to Im by root 2. Okay, all clear? Next we are going to find what is meant by the RMS. So what is meant by RMS current? So we know that what is meant by RMS. RMS is root mean square. Root mean square current, and also it is called as effective current. Okay, root mean square current or effective current. So we know that AC power P average, that is equal to half Vm Im. Okay, half Vm Im, also Vrms into Irms. Okay, here a special value, that is Vrms and Irms, used in AC current. Why? So what is meant by RMS current? So RMS current means I is equal to under root average mean of square of current. So RMS is root mean square. So first root mean it is meant by mean and square. Okay, so you understood RMS of current means root mean square. Okay, so you know that I representation in resistor, that is Im sin omega t average. Sorry, I forgot about the square. Root mean square. Okay, next we have to find the square. First of all, we have to find the square. We know that Im square sin square omega t. So Im square is a constant and we have to take outside. So root for outside the root Im square, it is like Im, root of Im square, and root of average of sin square omega t. We know that the average of expectation or average value of that sin square omega t, it is half. So Im into half under root. So Im divided by root 2. 1 by root 2 value is 0.707. So I is equal to 0.707 Im. 0.707 Im. So I is equal to 0.707 Im. So IRMS is equal to Im divided by root 2 or 0.707 Im. Okay. So you understood about that things. So you know what is meant by IRMS. So similarly we can write what is meant by RMS voltage. Okay. So now we have to change that marker color. So it is also called as effective voltage. 1 VRMS, you should know Vm by root 2. How we know that? VRMS is equal to root of mean of square of Vm sin omega t square. So Vm under root square of sin square omega t mean, that's equal to Vm by root 2, that is 0.707 Vm. So we know that things VRMS is equal to Vm by root 2. Okay, you understood these things? Okay, so you know that VRMS, what is meant by VRMS and what is meant by IRMS. Okay, next we have to study what is in inductor. For that we have to done in next class. So you remember all these things. Okay, so what is meant by alternating current? Alternating current, it is a current like a sine function which is varies with the time. AC voltage is a voltage varies with the varies like a sine function with time. And AC voltage, it is preferred more because it can be converted from one voltage to other by means of a transformer. And also the AC current can be transmitted over a long distance. It is very economical. Okay, and what is representation of AC current and voltage? A vector, a rotating vector can be used. It is called phasor, and it is rotate about the origin and in anti-clockwise with an angular speed omega. And its length represent amplitude, angle represent phase, and projection of that vector on a vertical axis will give you the instantaneous value. And if there is two phases, the angle between them will give the phase difference. And we studied about the AC voltage applied to a resistor. Here we are considering an AC and a resistor, and we did the Kirchhoff law, and we know that Kirchhoff law Vm sin omega t minus IR is equal to 0. Okay, because Vm sin omega t, which represent the sine function which is in a AC voltage, IR, we know that the voltage across a resistor is equal to IR, and I is equal to Vm sin omega t divided by R, that's equal to I is equal to Im sin omega t. So we get I is equal to Im sin omega t, D is equal to Vm sin omega t, and that is in phase. We know that the phase is same. So Vm sin omega t, the phase is same, the amplitude is just a small change, that is Im is equal to Vm by R. So the amplitude of that current, it is smaller than that as the Vm, and but the phase is same because the minimum and maximum values at the same point. And that pure resistor, we get the voltage and current as like this, and the phasor diagram, the length of the voltage, the length of the phasor will give the phasor quantity amplitudes. The voltage of that AC voltage in resistor is bigger than I, because that I length is smaller than that, but the phase is same, so that is in the same angle omega t. And what is meant by power dissipated in the resistor, that we know that the current value, sum of instantaneous current values during each cycle is 0, but that does not mean that the power is 0. The instantaneous power, we know that the Vm sin omega t into Im sin omega t, so Vm Im sin square omega t. So the average current, that is current during in each cycle is 0, but that does not mean the average power is equal to 0. The average power is equal to Vm sin Im sin square omega t average, that will give you sin square omega t average is equal to half. That can be represented as average of power is equal to Vm by root 2 into Im by root 2, that's equal to Vrms into Irms. So what is meant by RMS? RMS is equal to root mean square. And how we know that these things, and we can take these things and as sin square by half, and under root we get I is equal to Im by root 2, that is IRM is equal to Im by root 2. 1 by root 2 is 0.707. So IRM is equal to 0.707 Im. VRM is equal to 0.707 VM. So VRMS and IRMS we know that. And power average of an AC applied to a resistor, that's equal to VRMS into IRMS. Okay. Thank you.